Hi, and welcome to the 10 square meter workshop. I'm Mike, and this is part 2 of my CNC video. Today, I want to talk about 3 enhancements to a CNC machine that are really worthwhile. They are an emergency stop button, a Z-axis sensor, and an automatic control of the spindle and extraction system. This applies directly to the workbee machine with Duet 3D controller, but it is applicable to other machines.
There is an emergency stop button on the control screen, but there is nothing faster than a big red button within easy reach. Here, the switch has been mounted in a standard electrical junction box. Ideally, you want a normally closed switch, such as this miniature panel switch. You can glue on a plastic bottle cap for a button. Paint it red for the full effect. You can use a normally open switch, such as the doorbell, but this is not as good. Normally closed is fail-safe. Route the 2 wires, polarity is not important, and connect to the outer 2 pins of the plug that fits into the Duet control board here. Now to enable it, in the control panel, go to File Management, System, and open customconfig.g. Add the bottom 2 lines, as shown here, and then save the file. Perform a screen emergency stop or power off and on again to load the new file. Don't forget to test it.
Now you have an emergency stop button. Gives you a lot more confidence. Next step is to fit a Z-axis sensor. This is so you can accurately place your tool the correct level for your work surface.
The Z-axis detector works by sensing the tool touching a metal plate. One terminal clips to the tool, the other is a brass plate. Brass is easy to solder the wire to. Single pin plugs mount on the other ends of the wires. These are inserted into sockets mounted on the Z-axis carriage. These are routed back to the controller and connect to the outer 2 pins on the socket shown here. The system is enabled in the control panel, where you also enter the plate thickness under Z-axis offset.
Finally, automatic control of your spindle and extraction. Having the machine switch these on at the beginning and off at the end is a major convenience and avoids the damage that forgetting to switch on the spindle can cause. I strongly recommend it.
First, you will need a 24-volt relay, capable of switching 10 amps or more. I use 2 relays, one for each function, as they can be mounted in more convenient places. Relays are available from electronic suppliers such as RS Components, or from eBay. My spindle relay is mounted in a small box on the gantry, where it switches the power going to the spindle. My power routes through the drag links. As an aside, I fitted a plug and socket to my router, so I can remove it if required. My extractor is switched in a small box mounted to the side of my enclosure with an override switch, so I can switch it on for manual cleaning in the enclosure. 2 wires are connected to the relay coil as shown. These are routed to the control unit, where they connect to the socket here. If you are using 2 relays, they both connect to the same control pins. The brown wire in the power lead is opened and connected to normally open pins on the relay, as shown. Take care with this and make sure the main supply is isolated first. When the wiring is secure, you will need to insert a G-code command to switch the power on and off. This depends on which software you are using. In Vectric, open the application data folder. In PostP, choose the post processor that you are using and edit in Notepad or similar. Add the M106 command as shown to the spindle on section. Add the off command to the end of the file commands as shown. Save the file. If you do not use Vectric, you can always add the lines to the beginning and end of your G-code files in Notepad.
Well, that is it for this video. I hope you found the content useful. Don't forget to subscribe for more workshop ideas. Till next time.